Okay, so first question from the homework I decided to have a look at was question 49. First two I thought were pretty straightforward, so you shouldn't really need much help with those. 48 I might come back to, maybe if you have trouble with it. 49 seems to be, the first maybe two-part question that comes into it. A, what is the molar mass of oxygen? Well, we did a lot of that in class, figuring out the molar mass. Oxygen, of course, is diatomic, so it's two oxygen atoms bound together. Each one has a mass of 16 grams. So then twice 16 is 32 grams per mole. Okay. Part B, what volume will be occupied by 1 kilo of oxygen at 25 degrees Celsius? So we want to jump straight in here and just apply the ideal gas law, PV equals nRT, but we can't really do it because we don't know the number of moles. So we've got the temperature, by the way, the temperature is given in degrees Celsius, so that means we need to add 273, so that's 298 Kelvin, 298 Kelvin. The pressure is 1.3 by 10 to the 5 pascals, so that's given in pascals, not atmospheres. The gas constant is 8.31 joules per Kelvin per mole, and unfortunately we've got the mass of oxygen instead of the number of moles. So that's the first stop really, is to figure out how many moles are in 1 kilogram of O2 gas. Okay, so kilograms, 1,000 grams, we're going to divide it by 32 grams per mole. Grams cancel and the moles comes up on top, so that gives us 31.25 moles of oxygen gas. Okay, so now we've got our N, and after that it's very straightforward. We now substitute in the number of moles. We've got everything else just lined up, so I guess we'll finish it off. I've got a number of moles, 31.25 moles, and I'm going to include the unit. I think it's a really good idea. 8.31 joules per Kelvin per mole, and the temperature is 298 Kelvin, divided by the pressure, which is 1.3 by 10 to the 5 pascals. Should give me a volume in meters cubed. So moles cancel with moles, Kelvin cancels with Kelvin, and I'll show you where that comes from in a second. My answer, so the answer I'm getting is 0.595 meters cubed, which is a considerable volume really. It's a meter times about 0.59 or 0.6, so about 2 foot high by a meter by a meter. So that is the volume that 31.25 moles or 1 kilogram of oxygen should take up. And of course that's at a slightly higher pressure than normal atmospheric pressure, so that's 1.3 by 10 to the 5 pascals, so that's a good bit higher than normal atmospheric pressure. I'm just going to walk quickly through where the units come from on this and how you can tell what the volume is going to come out in. So again, just looking closer at the units, I know I'm multiplying moles times joules, Kelvin, moles to minus 1, Kelvin over here, Kelvin's above the line, that one disappears with this one, the moles cancels with that moles over there, so that gives me joules divided by pascals. Now it's important for us to understand that Pascal is unit of pressure, and pressure is force divided by area, so that's newtons per meter squared in base units. Okay, It's also important for us to understand that the joule is the Newton times the meter, and of course that can come from various places really. It's all a form of energy. Joule is a form of energy, so you can look at maybe work done as force times distance. Probably that's the easiest one. That's newtons times meters. Or you can look at kinetic energy and it'll still work out to be Newton times meters. Or you can look at potential energy and it'll still be Newton times meters. It doesn't really make a difference, okay? So that means that I wind up with a unit of newtons times meters on top, because of joules, divided by the Pascal, which is newtons per meter squared. So I'm going to write that meters squared to the -2. Now my newtons will cancel, and what to do with these guys. So I've got meters, maybe it's easier for me to write it like this. I've got meters divided by 1 over meters squared. So if you want to think about your rules of fractions, I've got meters on top over 1, that's meters over 1, still just meters, divided by 1 over meters squared. You invert the divisor and multiply, and that gives us meters cubed. Okay, so I guess quick rule of thumb, if your pressure is in pascals, then you will have, and of course you use the gas constant in joules per kilogram per mole, then your volume will come out in meters cubed. Sorry. Okay, hopefully that makes sense.